Okay then, here's the question then. Parts A, B and C. And I've got it summarised here. The first part is a trapezium rule, so let's have a go at that then. 5 ordinates, 4 strips to find an approximate value for this. 8x cubed plus 1 square rooted between 0 and 2. So B is 2 and A is 0. So 2 minus 0 is 2. So I'm going to put that in straight away. It's 5 ordinates or 4 strips. So n will be 4, the number of strips. So let's put that in. So 2 over 4 is a half. And h over 2 will be a half over 2 is a quarter. So I'm going to write that in straight away from the formula which has been copied in from the formula book. So we've got x0 then. We've got x1. 5 ordinates, so it's x2, x3, x4. The first one was 0. The last one was 2, and we're going up in halves, aren't we? Okay, and then we need to work out the y ordinates, of course. y0, y1, y2, y3, and y4. And it's, what is it? Let's have a look. It's 8x cubed plus 1 square rooted. 8x cubed plus 1. 8x cubed, that's 0. Cubed is 0 times 8 is 0 plus 1, so it's just 1. And then here, let's do the last one. 8x cubed, so that's the square root of 8 times 2 cubed plus 1. 65, that one. Next one then, put half in. 8x cubed, 8 times a half cubed plus 1. That would be 1 plus 1 is equal to root 2. Then the next one, 8 times 1 cubed plus 1, isn't it? So that would be square root of 9, which is 3. And then this would be square root of 8 times 1.5, which is 3 over 2 cubed, plus 1. The 2 cubed and the 8 cancel. 3 cubed is 27, plus 1 is 28. Oops, 28. Put that in properly. I'll leave it as an insert form here. So if we label this I then, and that will be our solution for the trapezium rule, I is equal to 1/4 then. And it's the first plus the last. Here, y0 plus y4, so it's 1 plus the square root of 65, plus 2 lots of everything in between, isn't it? This one, and this one. So that'd be root 2 plus 3 plus root 28. Close that bracket, close the brace, and we just need to tap it out on the calculator then. And we need to work it out to, let's just go back up to 3 significant figures. So let's do that then. So it's equal to 0.25 times bracket 1 plus root 65 plus 2 times root 2 plus 3 plus square root of 28 outside the square root. Close the bracket for that 2 times and close the brace. Equals 7.1184, 7.1184, which equals 7.12, isn't it, to 3 significant figures. So that's part A done. Okay, good. So describe the single transformation that maps this onto this. Okay, maps this onto that. So y is equal to square root 8x cubed is 2x cubed plus 1. Maps that onto this one, x cubed plus 1. Oops. Okay. Okay, that's what we've got there then. So basically, maps this onto this. So the 2x becomes an x. So if it were 2x as a line, it would map onto x, wouldn't it? No, which is 2x goes to x. So that's going to stretch it, isn't it? So it's a stretch. Along the x-axis. By, well, it's by a factor of 2, isn't it? By a factor of 2. So that's what it is. We saw it from that simple little idea of the straight lines there. So that was part B. So we've done that. Now we need to turn our attention to part C. So y equals the square root of x cubed plus 1 is translated by 2 minus 0.7 to give the curve with equation y equals g of x. Find g of 4. Okay, so 2 minus 0.7, y equals square root. Let's write it down first of all then. Y equals the square root of x cubed plus 1, translation by 2 minus 0.7. So, okay, minus 0.7. So if it's shifted forwards, it would be the square root of x minus 2 would shift it forward cubed, wouldn't it? And then if it's dropped down by 0.7, the y value needs to be plus, doesn't it? Y plus 0.7, that's the translation there, plus 1. So let's see what the question asks for then. Find g of 4. So, g of 4, so this would be, okay, so let's work it out then. So the new function would be f, this would be g, wouldn't it? Sorry, let's just write it down. So g of x would be equal to this, cubed, plus 1 minus the 0.7 then. And we need g of 4, don't we? G of 4 then. 4 minus 2 cubed is 2 cubed, plus 1 minus 0.7. 9, square rooted is 3, minus 0.7 is 2.3. That's part C.